guess we can finish all the stuffs before 9. So we have we can leave a bit earlier. Finally, yes. So today is the last lesson talking about the basic electrical theory and electronic circuits. So today we will have a bit more calculations. So we'll go through some decibels, as you can see. Let me check. Decibels, calculation of powers. Because I found that I missed the calculation of powers, and we'll go through Q factor, and some more concepts in the of like electronics. Yeah. We'll also go through like transformer, because transformer will be asked in your exam, like step down or step up, how much voltage, that kind of stuff. What is the ratio behind? And there are some more just for your reference, and I will talk about it when we meet this kind of concepts. And finally we'll go through some filters, like what is this used for, and yes, and transistor, what kind of thing is this, which is about the electronics components. So this, you see, we just got 88 slides today, not a lot, just the same number of slides as before. So we can go through it a bit faster. No, we are not going these slides. Just a minute. Decibel. Okay. So what decibel is? Decibel actually is a measurement of you can say it is a comparison between two numbers. Okay. Deci means 10. Okay, a factor of 10, and yeah, you know that it is. And bel means a logarithmic ratio. So logarithmic ratios goes like this, okay. No, like exponential, inverse of exponential. Okay, so you can compress a very large number into smaller numbers. Okay, this is why we use the decibel, and we try to compare the size between two numbers. Yeah, maybe the scale, a number is very large, but the second number is very small. So we try to compare them with using a scale. So decibel will be the best scale for us to use, because if you use linear scales, the number will go very big. But we use logarithmics, numbers will go smaller. Yeah. Okay. So we'll have to go through the basic definition first. This materials appears in your in my Chinese class. So I will just go through it first, but I'm not sure if they will ask you in the exam. Probably not. This is a history. Okay, this is just a history. You are not going to meet this. Okay. Okay. The basic definition of 0 dB. dBm means 1 milliwatt. Okay, 1 milliwatt. Actually, you can also write it as 0 dBmW. You can also write this as 0 dBmW. The MW means milliwatt. Okay, so it's in the past, the definition means 1 dBm, 0 dBm means is have a reference point at 1 milliwatt. Okay, so 1 dBm is about, and 1 dBm is 1 decibel greater, which is 1 point blah blah blah. You don't have to remember this. Okay, I haven't highlighted. Okay, so the definition of 0 dBm is 1 milliwatt go through a 600 ohm resistor. Okay. Why we have this weird definition is because we used decibel in the telephone line in the past, and the telephone line used a 600 ohms impedance, have a 600 ohm impedance. Okay, so that's why they take this number as the magic number. Okay, but you don't have to remember this in your exam. Just remember that 0 dBm have a reference from 1 milliwatt. Okay. Okay. So you see that historically this reference telephone lines. Okay. Okay. So the dB has a reference scale like this. Okay, 1 First you have to have 2 points for your calculation. The first point is the m. The m is the number you want to measure, okay? The number you want to measure. And the p reference is the reference point you have to compare, okay? Which is, you may think that this is the output, this is the input. M is the output, and reference is the input, okay? So sometimes you want to measure what is the dB gain or dB loss, okay? After you pass through the amplifier or some resistance, if they have a power drop, okay, or the signal loss, okay. Okay, so that's why the okay. So for a power, it is very easy to understand. You use normal logarithmic scale, so that's why you have a 10 at the front, okay. So how come they have a 20 for voltage? You can think in this way. Still remember that P equals to, what is power? Power equals to voltage times current, right? Power equals to voltage times current. So you can rewrite your formula into P. I don't have to use my iPad today because I haven't set up my whiteboard. So I will just use my board. Let me grab a. Oh, thank you. How come they haven't erased the board? Never mind. Okay, you can say that. P equals to IV, right? And V equals to IR. So therefore, P equals to V square R. Okay. So you see the power is directly proportional to voltage square. Okay. Let me grab a paper. I want to just do they have any tissue here? Great. They have whips today. Thank you. No. Okay. Great. Great. The reason why I have to go through this is because if you remember the formulas, if you can remember the formulas, so no, I mean if you can use the formulas in our last lesson properly, if you have a good understanding of the materials in the last 2 lessons, you have less things to remember. Okay, that's why I have to go through them one by one. Great. Oh, they already teach the how come they already teach the crystal already? Never mind. I will just go through I will go through the crystal today actually. Hope that I'm not behind schedule. Well, we have just talked. P equals to IV, right? This is the definition of power. P power equals to current times voltage, and V equals to IR. That's why P equals to V square R. So this is just a combination of these 2 formulas. Okay, nothing new. Okay. As we can see, the dB has a definition of. Do anyone don't know what is log? I hope you guys all.
Yep, still remember a little bit.
Hey, I can't erase this one. Who will be? Never mind. I will just leave the problem to dictation. No, this is. What is this? Oh, that's a good problem. Never mind. I will just leave the problem to them. I'm not going to deal with this problem today. Yeah, get it permanent. How come they put the permanent marker over the? Okay. For a log scale, you usually use base 10. Okay. Because the math I have not put the math in my notes. It is very hard to do so. And log base 10 for 100. So you can rewrite in this way. log to the base. Okay, I have to pick another marker. Thank you. Oh,
Erasing.
yes, erasing. I'll have it. They don't have a good pen.
Well, yeah.
Thank you, thank you. They don't have a good pen. I'll come. Oh, but this is good. It is good. I will use this. 100. Okay. So you can rewrite into a log base 10 to the power 10 over 2. Okay. So you can write it this way: 2 log base 10 to 10. So log base 10 to 10 equals to 1. So it's equals to 2. Okay. This is how you do the log math. Okay. You try to change this number same as the base. Okay. So if the base is the same, you can cancel out the 2. You can move at the front. Okay. You see the 2 here, right? So in the log scale, what? P yes. P equals to no. dB equals to log base 10. Okay, all the stuff we use is base 10. Okay, so you have to remember. P out over P. Okay. So if all the powers become V squared, so actually we got log 10 to V square out, V square in. Okay. So actually these two you can put it in the front. So that's why they got 10 here. Okay, 10 here. That's why you got 20. Is the reason.
We trust you.
Yes. So that's why you got 20. Okay. Just think it this way.
Alright.
Otherwise, you will be very hard to memorize why you have the 2. Yeah, this is use 20 for voltage instead of 10. It's because of this one. The ratio is a power. Okay. I try to remove it. Don't leave the problem to others. But I don't think I can. Anyhow, let me see. Can I solve the problem? A bit better.
Yeah. How about using calculator?
Yes, I think Echo is the best. Thank you. Oh, good. Last time I also used alcohol. When I was in my university life, I used acetone a lot, which is like absolute, and this is the best solvent. Can be buy easy. So if you can't have if you can't erase something, just you try to use acetone. But if acetone can't help you, then you're in trouble. That means most of the stuff cannot be erased. You cannot remove the solvents. Okay. Yes. So if we have just talked about from dB to power voltage. So you know how to do the dB. It is to -1, right? Okay. Do I need to do the math for you? Yeah, you can just do it.
Pick it up someday.
Yeah.
Not tonight.
Log to the -1 is just 10 to the power. Okay.
Log to minus.
Yes. We have just said dB watts. I'll emphasize this dB watts. Okay. dB watts equals to 10 times log P in over P out. Okay. So if you have a dB here, you can move the 10 here. So it will become dB watts over 10 equals to log 10 out. Okay, so that's why P in, P out. Okay. Log A B equals to inverse log. Okay, how should I express it? Okay, if I have number log base 10 100 equals to log 10 to the power 10 squared, and it is 2 log, and it is 2, right? So that's why if you have the 10 to the power 2, okay, just give you a definition. I'm not going to extend example. Okay. 10 to the power something. So 10 to the power something equals to inverse log. Okay, just equals to. Okay, they're the same thing. Okay, inverse log is just 10 to the power something. Okay, so you can put the log here, which means 10 to the power dB what over 10. This is how you do the calculation. So you see the calculation now has become the same, right? From this calculation, moving a few terms over the right side, you can get this one. 10 to the power something. You can rewrite it as log negative 1, but I don't like to use this kind of notation. Yeah, this is how you do it. And for voltage, it's just have a extra two. So I'm not going to explain how to do it. Okay, example. So you can calculate on your own. If an amplifier turns a 5 watt signal into a 25 watt signal, what is the dB gain? Okay, we are trying to do the dB gain. So anytime if you do the dB, make sure that it is not always 1. Okay, it is not always 1. Okay, but if they didn't give you the reference point, you know that it will be 1. Okay, 1 dB. Okay, always check the reference first. Okay, if they don't have the reference, then you should just put 1 at the back at the denominator. Denominator. Yeah. Okay, so I have to do the math for you, right? I don't have.
No,
They got
it's easy.
Okay, yeah.
So what you're saying is, if you want something to be double in terms
Yes.
of volume,
Yeah.
you need a huge increase in voltage,
Um.
and you're calculating this formula.
Oh. Not really. It is. I should put it this way. If you have a input and output ratio like this, I'm trying to measure maybe this. I will measure the signal strength. Okay, it is about the signal strength, how strong the signal become, and we say it is 7 dB gain, which is 7 dB stronger than before, stronger than the original. So dB is just a comparison before and after. Okay. But not how much voltage you have to put in to amplify the signal. Yeah. And there are some, if you are very good at math, you can't see the whiteboard. Of course, 因為我冇呢個嘅，我都冇駁線. If you want to see the whiteboard, just come to my class. I don't want to set up the cam. Really, it's very hard to set up things. Let me see if I can set up the stuffs. Let me see. Okay, just a second. I'm worried that I don't have enough battery today. I'm not sure. I need to charge my battery when I go back home. So we got something like this last time, right? Let me explain it once again. Okay, before we got things like this. P equals to IV, right? And V equals to IR. That's why P equals to V square R, okay? And dBW is the definition of 10 log, don't ask me why, it's by definition, okay? P out, P in. Okay, as your voltage is squared, you can think in this way, which is 10 log V square out, V square in, right? And this 2, you can put it at the front, which becomes 2 times 10 to the power log 10 V out, V in. That's why they become 20. Okay? So that's why dB voltage, okay? This little number here stands for what you are trying to refer. If they don't have anything at the back, most of the time it is measuring watts, okay? If it is just a dB, means dB watts, okay? But if they are good, they will give you a W, okay? Sometimes you may also see numbers like dBm, okay? So it is referring to milliwatts, okay? Okay, so what I'm just trying to do is, I'm trying to do the math stuff. Let me delete this thing. Good. Hey, I've really found a good software. Let me see. Okay, we do the log again. We try to do the inverse log, okay? Log base 10 x. Okay, log by definition, log y x. Hey, you can't see this one. Is equals to let me see. No, I don't have a good equals to y, no, equals to, let me see, 100 times 2 means 10. Okay, y should be put here. It's y. Oh, I forgot. Never mind. I don't want to make things too complicated. Okay, just think in this way. 10. If you have things like 10 to the log 100, log 10 base 100, which is becomes 10 log 10 to the power 2, and you can just throw the 2 at the front and becomes log base 10 10, which is equals to 2 times 1. Okay, you can do it this way. So you can see that log base 10 is reverse of 10. Log base 10 x is just, if you have to do it, is just 10 to the power something like this. But it is a bit wrong, but I've just an illustration. So if you do the inverse stuff, log base 10 is 10 to the power something, okay? Okay, once again, and we just talked about dBW is 10 to the power 10 times log base 10 p in p no sorry, it is p out p in, right? So we have to move this 10 to this side, which becomes 1 over 10 dBW. dBW just treat it as a variable first. Log base 10 p out p in. Okay. So for this part, if you move to this side, it will become 10 to the power dBW over 10. Okay. So by just some magic, you will have dBW over 10. Think like this. Okay. This is how you do the magic. Really magic. So if they ask you about how an amplifier turns from 5 watt to 25 watt, what is the dB gain? The dB gain becomes 25 over 5, right? dB watts become 10 to the power log 25 over 5. So at this time, you can grab a calculator and do the math. 10 to the power log 10 5, right? Equals to 10 log let me see. So it becomes 7 point blah 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 dB. Actually, from this part, from this part, you can already do your calculation. You can already grab your calculator and do the calculation. This part, okay? You can already do it. You can already get the answer. And we don't try to do a lot of complicated math today, or in our lessons. But there are some more numbers I would like to tell you. Some magic numbers you have to memorize. Okay, let me explain it. Yes, this is the magic number. Plus 3 dB, plus 6 dB, and plus 10 dB. 3 dB is 2 times the original power. 6 dB is 2 times 2, right? It is 4. It is 4 times the original power. 10 dB is 10 times stronger, and the negative is just a fraction, becomes a fraction. Okay. I didn't have my calculator with me today, so if you have your calculator, you can help me to do the math. dB watts. Okay, as we've just talked about, dB watt equals to plus 3 dB, right? So 3 equals to 10 times, no, 3 equals to 10 times log base P out P in, okay? Equals to 10 to the power 3 over 10. So you can calculate what is this number. Let me open an Excel. 10 to the power 3 over 10. Yes. So this number is around 2, okay? This number is about to be about 2. So if you have number doubled, so you immediately know it is 3 dB. Okay. So if you don't know how to do the logarithmic very easily, just remember that 3, 6, and 10. These are the magic numbers. Okay. 3 is 2 times, 6 is 4 times, and 10 is 10 times. Okay. Why 10 is 10 times? Because by definition, 10, if this is 10, then 10 log 10 p out p in, right? And 10 over 10 is 1, right? So it's become log base 10. No, it's not base log base 10. It's 1 equals to log 10 p out p in. And 10 to the power 1 is just 1, right? So that's why if you have a plus 10 dB, it is just 10 times multiply as 0. Okay, this is how you do the math. And if it is a negative number, I have also to do the negative numbers to you. I will choose 96 dB as an example. It will become 10 log. Actually, it will be asked in your math. It will be asked in your exam. But I just use power as an example. If it is voltage, then it is just 20. Okay, nothing interesting, nothing new. Okay. Then you know that it's become 6. Negative 6 over 10 equals to log 10. I will just skip this part. I will just give a p. Okay, I'm lazy. P equals to 10 to the power negative 3 over 5. So you can know what is 10 to the power negative 3 over 5. Let me grab my calculator key. Excel is a good tool. I love Excel so much. So that's why you have to, if they really give you very weird numbers, you will have to you have to calculate using a calculator. Okay, from my answer, it is 0.25, right? 10 to the power 3 over 5 is 0.2511. So you know that 1 over 4 divided by 4 is 0.25. So that's why we will say, let me add this one for 0.2511. Okay. So that's why 1 over 4 is equal to 0.25. That's why we said that negative 6 dB equals to 1/4 of original. Okay, this is how you do the math. The proof will not be asked, but if you are really bad at math, I have shown you in why we have a table like this in a mathematical way. So just believe me. Okay, these are magic numbers, and you will see some more magic numbers in your still remember when we talk about the laws, right? The laws. You have in your NXP1, they give you a very large chart saying that how much dB watts can be used. 14 dB watts, 7 dB watts, right? So you now know that 7 dB watts is what is meant by 7 dB watts. 7 dB watts means 5 watts. Do you know what I'm talking about? 7 dB watt. If they don't give you the original input, we will say that the original input is 1 dB, 1 watt. The 7 dB watts equals to 5 watts. Okay. If they didn't give you the original power, so if they don't give you the original power, we will say that 1 watt is the input or the anchor point. Okay. So they will give you 7 magic numbers. Like you have to also remember 7 dB watts, 14 dB watts, 20, and 26. These numbers appears in your exam. So if you are not good at math, you can't calculate it on during your exam. You can calculate them beforehand. But if not, you don't have to memorize a lot of stuff. Just remember the original formula, and you can do all the stuffs during the exam. And you have enough time to do all the math, including proof. 3 hours is too much for the exam. You can just finish the exam at around 1.5 hours. Yeah. Okay, example. Still remember that we talked about the ERP. The ERP is the emission rectified power, right? So we use the ERP to measure how much gain is included. So they may ask you something like this. If they have amplifier and they have a loss in your power, what is the final dB? How much the voltage, how much the power gain, or how much the dB gain in your final circuit? They may ask you things like this. Okay, let me give you the answer so you can calculate it on your own. It is 17 dB. Okay, I'm just kidding. Let me go through it. Let's go through it once again. Okay. So for logarithmetics, okay. If they have log 10 to the power 2 plus log 10 to the power 3, okay? You can have something like this, okay? This is why you have from multiplication to addition, okay? This is the conversion in math, okay? So if they already give you the dB, you don't have to convert them back to watts, okay? If they just ask you what is the RF power radiated, blah blah blah, just a second, okay. You see that there are a lot of components here, right? You don't have to calculate from this point, calculate at this point what is the watt, at this point what is the watt. No, you don't have to do this. If they already tell you it is plus 6 dB, plus 10 dB, minus 2 dB, at plus 3 dB, you can just go to it directly. Let me do the math. It is 6 dB. It is 10 dB, minus 2 dB, and plus 3 dB. Okay. So your final gain in circuit is 7 plus 7 dB. So you know that every if you just dB on its own, you can just add the numbers. Don't worry, you can just add the numbers. Okay, you can just add the numbers. Okay, so you now know that now the gain is 17 dB. The original input is 2 watts. P in is 2 watts. What is the P out? Okay. dB watts equals to 10 log base 10 P out P in. So you know that it's a plus 17 equals to 10 log base 10. I just I'm lazy. Log p equals to 1.7. So p out over p in will be 10 to the power 1.7. We know that p in is 2, right? So p out is just 2 times 10 to the power 1.7, and you'll get the answer. What is the answer? I actually don't know. It is 100.2. So I have to calculate this. We have to do the math. Let me see. 2 times 10 to the power 1.7. Yes, I make the yes. So it is 100.23. So it is 100.24 watts. Okay, trust me, I do the calculation correct. Okay, so that's why they have to give you this number. And oh, let me show you my calculation once again. Where's my calculation? Okay, here. Oh no, here, right. Trust me, this is how you do the math. And because it will ask you some questions on power, so that's why you have to make sure you know how to do the dB, and you meet the dB, you meet your friend again and again if they talk about the when they talk about amplifier and the circuit gain, okay, gain and loss, okay. That's why I have to talk about it first. Otherwise, you will feel very not inconvenience, but very not misleading. How should I address this word? Confused. Yeah, you will be very confused if I don't talk about this part. And I expect, and why I use ERP is because ERP, this keyword appears in your Annex B1, right? No, Annex A. When they talk about laws and regulations, they talk about this keyword. That's why I have to mention how can you calculate now. To recall your memory, okay? And some special reference. We have DBD, but DBD is not that common to be seen, okay? DBI, you have seen it already. It is we call it isotropic antenna, which is just a line, and it radiates just like a donut shape. It is we call the isotropic antenna. Do I have to draw it? My drawing skills is really bad. My drawing skills is really bad. But I will show you. If they talk about an isotropic antenna, it will become, let me use a different color. They actually do it in a donut shape, okay? It will radiate in this way. Okay, this way. This is we call an isotropic antenna. But a dipole, I haven't prepared my notes yet. But dipole antenna looks like this, or we call it half wavelength. Okay, half wavelength. This is the dipole, but I'm not going to go too deep on it first. Yeah. So that's why if they have one more reminder to you, 0 dBd or 0 dBW equals to 2.15 dBi, which this equations appears in our very first lesson, and I did not include it in my notes. This is when you all the time. If we talk about antenna, most of the time we are talking about this one, okay? The dipole antenna, but not the isotropic. So that's why if you see there's some antenna saying that hey, I have a 0.15 dB gain antenna, but you see that it is a dBi here, so this means there's no gain. It's just a normal antenna. Okay. If they don't mention it, treat it as dipole. But if they mention it, you have to realize which one they are talking about. They may trick you, but I'm not sure. But you should know this. dB milliwatt, voltage level if they are milliwatt, micro, mil, micro. Yes, this is weird. Milliwatt. You see the definition, our 600 ohm definition. If it is a watt, sometimes they may just skip the back. Okay, you see that dBm. Okay, they may skip the MW, the watt. You can skip it. Yeah, it's already known. Okay, if you skip it, we are referring to watt. And mil, just mil watt. Just some symbols. Okay. Q factor. I really don't want to talk about this one. It's very weird. Okay, Q factor is math. When we talk about the selectivity, okay, or we say how pointy. Yeah, we measure the selectivity. Okay, just remember the selectivity. Let me show you a graph first to let you know what is mean by selectivity. You can see that if your antenna will respond in a very, very low range and the gain is very high at this point, we say that this is a very high Q factor. What it means by selectivity means they will only respond or receive the signal at this tiny gap. Okay, this is what we call selectivity. Only choosing a very small range of frequency. We call selectivity. But if you say that, hey, it is a green curve, it will respond to a very wide range of frequency, and the dB gain is a bit lower. This is we call a very low Q factor, a low Q factor for the green curve, and it is not good. In the world of radio, we always want to have a very high Q factor, so that we have band planning, right? We try to use narrow the band as possible, so that we can leave more space to others and we prevent interfering others. You don't have to do the math. Okay, you see that. For your reference, just the definition. Okay, we have a definition based on the reactance and yeah, think of this. But no, we are not going to do this one. We'll just use this one. Okay. Again, this is not asked in your exam. Okay, this is not asked in your exam. What I'm trying to point out is you will always see this one. This is very important. You see that this is negative 3 dB band. Okay. In our syllabus, we emphasize a lot on what is negative 3 dB. Okay. Yeah, just think in this way. You have to mark down all the stuff, right? You see that this is they draw a line at this weird point, right? At the red line, they draw a point here, right? This is we call the negative minus 3 dB point, where the power is halved. Okay? If the power is halved, the voltage is what? The voltage is 0.307. Let me grab my iPad here. Okay, if your power is halved power, which means your voltage is 1/√2 voltage, right? Cos P equals to V square R, and R is a constant. Okay, so that's why half of power means 1/√2 voltage. You have to do the square, right? Okay, and 1/2 is 0.707 V. Okay, so at negative 3 dB point, the power is halved. Okay. Why it is halved? is because still remember we do a lot of math here, right? 3 is a magic number. 3 is a magic number. Plus 3 dB, 2 times larger. Minus 3 dB, half of power. Okay. So if power is half, voltage is, hey, how come I can't, hey, never mind. Power is power is 1 over root 2. Okay. Or you can do the math your own. The voltage is 20, right? I'm not going to do the 20, but if you really want to know the dBV, right? 20 log power out, power in. So we already know that it is minus 3. So minus 3 over 20 equals to log P out, P in. 10 to the power negative over 20 equals which it should around this number. You can try to do it on your own. Or do you want me to do the math here?
No, we trust you.
You trust me. Okay, trust me. Yeah. But if my calculation is wrong, you see this one, right? So you can remember this one. Half power half. Oh, I guess I'm wrong. Actually I'm wrong. But just never mind. Let's just remember this one. Negative 3 dB. This part is correct. This part is correct. Okay, this part is correct. Emphasize this one. 0.07. Okay, so that's why at negative 3 dB point, power is halved, and voltage is 0.707 as original. Okay, so that's why it is at this one. So you will see that it is actually 0. We use this point as comparison, the peak as a comparison. So it is 0.7 as original, 0.707 as original. So we draw a line here. Voltage gains 1 over root 2, power is halved. So that's why we defined in all our definition, when our filters work, or antennas work, or the Q factor we measure it, when the power is halved, we will take this point beyond or lower, above or lower, as the zone is not working. Okay, only within the 3 dB, negative 3 dB point, it is the working frequency of the filter or of the antenna. Okay, that's why we just measure this little range here. Okay, that's why we measure this little range here for the red filter. Okay, for the green one we will measure here. This we called so you see that the negative 3 dB points goes very long. Okay, so that's why we have a very low Q value, very low Q value. Okay, just remember that it is related to the negative 3 dB bandwidth. Okay, yes, you meet a lot of this kind of concepts. Another here. Okay, at negative 3 dB points, we call it as the cut-off frequency. Cut-off frequency. So even though they still have some signals here, but we say that, hey, I don't care. I just cared from negative 3 dB, upper and lower. We just calculate here. Okay? Even though some signals may go, but we just ignore it, because the voltage is already, the power is already halved here. Yeah. We have talked about Q factor. Q factor is the measurement of selectivity from lower 3 dB to upper 3 dB. The narrower the range, the higher the selectivity is. They will select just a small proportion. The lower the Q value, they will accept a wider frequency range. But sometimes a wide frequency range may not be, we will select from case to case. Wider or narrower doesn't mean that it is better or worse. Okay, draw a line here yet. It depends on our use case. But for antenna, we of course we want our antenna have a high Q factor as possible. Okay, transformer. Transformer is, oh, they will ask you, I guess, but they will just ask you how much the ratio of coil is required to step down how much voltage. They will just ask you this question, I guess. But they have some very important concepts to go through. I don't know if how will they ask you about the transformer. Okay. So transformer, you can see that it is actually two coils. Having the two coils, right? The two coils. Do you still remember what is this one? The L. The L is this one. What do you? I have talked about this last time, right? What is this symbol? What is this? This is an inductor. Inductor. It's very important. You must remember this one. If they ask you the inductor and you can't remember, then you'll be in trouble. It's inductor, okay? In your case, if this coil is isolated, okay, in this case, we have an alternating current, alternating power, right? The alternating flux line, magnetic flux line, will cut through this coil, so that the electrical power will transmit it from L1 to L2. Okay. Using the not Lenz's law, Faraday law. E field generate B field. B field from here will generate E field, so that the resistance here will have the electricity. Blah, blah, blah. It's not important. I've just explained to you already. Okay, this is the real picture. So sometimes if you see your transformer, you see a very big metal coil, metal core. It's a core, okay? This magnet is we call a core, okay? Core. The coil is the wires wired on it, okay? The core will increase the magnetic flux so that it helps to transmit the change in B field better, so that the efficiency will increase, okay? The most important is just a picture illustrating, okay? Some more to go through. Just a minute, let me see. Yes, I haven't tell you about how to do the math yet. Okay, don't worry. Okay, it's Lenz's law. So when we have a changing B field, the coil resists the magnet, right? So we'll generate an opposing B field against the magnet. In other words, if the magnet is already inside the coil, when the magnet leaves, this coil will generate an opposing, attracting magnetic field to prevent. Why are you laughing? Am I wrong? I'm wrong. Just correct me if I'm wrong. If the magnet is already inside the coil, it will generate an attracting B field to prevent the coil from leaving. Okay. So that's why you see that it is attracting and it is preventing. Okay. So in this one, okay, the same concepts. If they have a B field here, this part will generate a opposing B field to prevent its magnetic change. This changing B field here will have an induced current and induced voltage. This is how the voltage is passed to the second coil. Okay, it's all about Lenz's law. It's very weird. Why I have to include Lenz's law here, right? It's because I found this keyword in the syllabus, so I have to add this one to let you know. Hey, at least you don't have to worry about this word. I haven't seen it. It's for your concepts, okay? Lenz's law is about inducing current. No. Faraday's law is about inducing current and inducing voltage. Lenz's law is about an inducted induced B field to prevent the B field change. Okay, so because of there is an opposing B field, we will have an induced current finally. Okay, B field to E field and current. Still you can understand, huh? Okay, finally we have math. Math is the easier part and easiest to gain a score. Okay. VP, VS means primary and secondary. And yes, we use the primary and secondary, the word. If let me just grab my iPad with me. I'm going to use my iPad for the explanation. Hey, I found that I have to make a new. How can I make a new? How can I make a new? Oh, great! I have a new pad here. As we have just said before, this is inductor like this, and inductor like this. Okay. If you do in a 3D world, my drawing is very bad. Okay. If you have okay. This is the primary. This is the secondary. Okay. If we have a coil, primary is greater than the secondary, it is a step down. Step down. The voltage will decrease. But if it is inverse, the secondary is greater than, I mean the number of turns, okay, number of turns. I mean the number of turns of coil, okay, is that. Voltage decreases, voltage increases. Okay. It is actually how you do the math. Okay. And if I tell you that, I use black cloud. Okay. The number of turns of a primary over n secondary equals to they are directly proportional. Okay. How large? Okay. Let me have an example. If your coil ratio is like your primary coil has just 20 turns and your secondary has 100 turns. Okay. Your voltage input is 5 volts. Okay. What is the output? The output will become 1 over, this is 1 over 5, right? times 1 over 5 equals to 1 over V second. Okay, so you see the power is 5 times, the voltage is 5 times increased. Okay, if you have a coil on one side is 5 times, okay, 20, and on another side, on the output side is 100. 5 times the number of turns will result in 5 times increase in the voltage. Okay, yeah. This is how what this formula tells you. Okay. I have to talk about why it is in this way. It looks a bit weird, right? How come the current is in the reverse way? Remember, current is in reverse way, okay? Please remember that. I don't want to see you guys being trapped. Okay, still remember that we have the formula once again, V equals to I out. So that's why if you remember this formula, you can have got a lot of score. If it is about electricity, you must use this one. We don't have any more complicated formulas. We won't ask you Maxwell equation, okay? Yes, because they are not that smart. They don't know how to deal with that. Okay, V equals to IR. Let me see. No, not this one. I'm sorry. Oh, but yeah, power equals to IV. This one should be this one. We know that in a closed environment, if we don't have any much power input or output in it, the power is always what? Constant. Second law of thermodynamics. Power cannot be created or destroyed. You will always have the same amount of energy in your circuit in an ideal case. Okay? So that's why if power is constant and voltage is increased, what will be I? I must decrease, right? Yes. Put it back in our I'm lazy. I just use N2 and N1. You know what I mean, right? V2 and V1, right? So that's why you have becomes P equals to IV. So it will becomes P over I2 and P equals I1, okay? As we note, P is the same. In a circuit, the power remains constant. So you can immediately know the P can be cancelled out. Oh. Yes. You have things like this. That's why it will becomes I1 divided by I2. Oh, yes, just a minute. Because I didn't see that. Just a minute. Yes, great. Can you see now? Let me go back here. Yes. Okay. Yeah, that's why it is inverse. Power remains constant in the circuit, and if voltage increases, voltage increase, currents decrease. So that's why you see the ratio is flipped. Okay, the ratio is flipped. Don't do it wrong, or I will be angry. No, I'm just kidding. Yeah. So you know the relationship. How can you deduce from math, or just think in this way? You got this formula, right? You got this power formula, right? Voltage increase, P equals to IV. We just make use of this formula to deduce how come the current is inverted. Okay. Let's have a very quick example. Just want to see if. Oh, how come Rudy is also here? I'm worried. Just a minute. Inductance. Oh, okay. A transformer has primary of 400 turns. And a secondary has 280 turns. And voltage is applied 120 volts. What is the voltage finally? So you can change this question into things like this. Okay. Once again, we know that Vs Vp equals to Ns Np. Okay. Yes. Or you can just do it in the reverse way. Okay. Actually, they're the same. Vp Vs equals to N P Ns. Actually, they are the same. They're equivalent. Okay. Because we are just talking about the ratio. Even the denominator and numerators are flipped, the ratio, you also do the same thing. Okay. So you don't have to worry about it. Just think it. The S goes on both sides. The S will go on both sides. Okay. We don't know Vs yet, but we know what is Vp, right? Vp is 120. I skipped the units. Ns is 28. Okay. 4 对 yeah, this is 7, right? Vs equals to 7 times 120. So you got it is 714, right? This is how you do. And let me check the answer. Yes, I'm correct. Very great. Still easy, huh? So you know that you can deduce this very quickly if you remember the formula. Okay. Okay. So as we have already tried what is the voltage, we will go through one questions in current. Okay. Secondary. Suppose the secondary of the transformer, okay, is delivering a 0.28 to the load. What will be the time? Okay. You can do it in either way. Okay. You can have two ways to do this question. One is you can still use the ratio to do it. Okay, this ratio, the ratio, what is? Let me drop it. Let me do the mark down all the stuff first. Otherwise, I will forget. Right? We let me try it next time. Okay. I'm not sure. The printer stuff. I don't know. Later. Okay. So you still remember that there is another formula. Ns over Np equals to I P over I S. Okay. And we know that the ratio here is 7, right? 7 IP, I don't know what is this, but IS I know it is 0.28. So IP becomes 1.48. The primary is 1.48. So you know that when the the current in the circuit is 1.4, and we once it go through a step up transformer, the current goes down, but the voltage goes up. Okay. So you can do it in this way. Another way is we have our old friend P equals to IV, right? You don't have to worry a lot of stuff. You just have to know in the circuit your power is constant. That's why P primary V primary equals to secondary V secondary. Okay, power remains constant. So when you have a primary circuit, your this is unknown. IP is unknown, but voltage you know that it is 840, and the current, oh no, this is not primary. What is the primary current? Primary current is 120, and IS, wait, what is IS? IS is 0.2, and VS is 840. You can still do it this way. Yeah. You see, I use both ways, and actually both ways will give you the same answer. Yeah. This is how you can do it. Don't worry a lot. Most of the math, all of the math here is just at most high school math, or even middle school math. Don't worry about a lot. Just if you have a very clear concepts on physics, you will immediately know how to calculate it. Okay. Impedance. It is root. Okay. I forgot if I have shown my calculation here. Let me check. But I don't know. I really don't know. Have I included proof here? No. Just a second. The proof goes here. Okay. You see the little. If you really want to know how y is squared, this is the proof here. But I don't think you need it. Okay. I don't think we need it. You can think in this way. Just think in this way. Okay. Once again, because V equals to IR. Once again, Ohm's law. This part is actually Ohm's law. You see that V primary, it becomes I primary, and Z. Z is impedance, which you can just think as resistance. Okay, V equals to IR, and you do some conversion here, and I primary over I secondary is just N secondary and primary, right? So that's why it is doubled. You can put a square here, and that's why impedance is root of the ratio, because you have got a square here. Okay, this is how you do the math, if you really do the math, but I don't think you need it. Okay. So that's why if just use your high school math, your middle school math can solve all the stuffs. Once again, we just because of two formulas, right? Ohm's law and the power P equals to IV. Okay, and actually this part is important. Okay, you see that it is by using the transformer, we can change the impedance of the circuit. Okay. So if you have a chance to open, let me see. Open this box up. You will see that they have mentioned a lot of things like 50 ohms, 50 ohms. I'm not sure if they have it here. I guess no. I guess no. Maybe not. Let me check. Probably not. Never mind. If you have chance, then we can check it. Okay. How come? No. I'm not sure why they don't put 50 ohms here. Okay, but never mind. For the transmission cables in our world, we usually use 50 ohms for the wires have an impedance of 50 ohms. Okay, so if your circuit does not have a 50 ohms, you should make sure they have a perfect match. And how you can do this is you can use an auto transformer to do the job. Okay, never mind. It's just a group of transformer. Okay, you can use the transformer to do the job. Transformer can help you to change the impedance so that you can make sure the impedance of your circuit matches with your radio or your transmitter. Okay, that's why this part is important in your real life. But in exam, you just have to know how to calculate it. Okay, and you can try it on your own. Because I have already talked about how to do the calculation. Let me see how much have I just go through. When did I start the lesson? Oh no! How come I just go through 26 pages? Oh. How come? Never mind. Just do it on your own. You know how to do the job. Just skip it. Auto transformer. Auto transformer is it's a very interesting form of transformer. The name auto means it's just use one coil to do the job of a transformer. Okay, just one coil. So you see that the coil here is just one coil, and we get a line from the middle or any points of the coil. Okay, so this part say this part is the input. Okay, the primary. Okay, then this part can act as a secondary. But if we flip it, if we use this part as the primary, we can use it as the secondary. Okay, this is how the auto transformer works. The same coil here can do both the job of primary and secondary. Okay, this is the auto transformer. So it saves spaces, and you don't need two coils together. Okay. But just like at the right hand side, we got an example here. So actually, like it will get put 5 points, 1, 2, this 2 points, and make 3 extra points here. So that when the circuit is connected, you can choose to step up and or step down. Okay? Using the same coil. Yeah. Just one winding, and yeah, it's step down, step down. For transformer, it can used for step up and step down. It can isolate two circuits if it is and two coil one. If it is two coil, you can isolate these two coil to protect yourself so that you won't short yourself. Okay, you won't short yourself if you accidentally touch it. In Chinese, it is called 電氣隔離, actually, galvanic isolation. So you can prevent shocking yourself. Impedance matching. Okay, I'll talk about impedance matching to match the transmitter and antenna. Okay. This is just some extra information for you, not in the exam, but you know that we got actually in our world we have a lot of step up and step down transformer. From your power generator, we will try to step it up transformer. So do you know why it have high voltages? It's because of V equals to IR once again. No, V equals to IR. Yes, V equals to IR. If we have very long wires, the resistance, or we say the impedance of it, is very obvious, very large, so that the current drop, if the voltage is very low, the current drop very fast. Okay, that's why if we have a very large voltage, the resistance, the current consumed is very little. We can save most of our current to the destination. That's why I have to step it up. But high voltage can cause electrical sparks easily, and it can be very dangerous. So that's why we have to step it down once again in our electronic, in our home. Okay, this 380 V is for 3 phases, and we normally use 2 phases. A single phase voltage is 220. Okay, just for your reference, and I include this picture to let you know why we have to have such a high voltage in the transmitting line. Okay. Skin effect. This is the only word they have included this word in the syllabus, and I have to explain it to you. But if you don't remember it, never mind, because we don't know if they will ask you in these questions. Okay. If you are transmitting in a very high voltage, they will just use the skin of this one. Okay, just use the skin part. In the middle, they don't transfer the electricity. It is about the impedance, and you can think that this is as a one single line inductor. So if it is in a high, oh no, never mind. Just think in this way. Just know it as a knowledge. For AC high frequency, the reactance is stronger in the center. So that's why they try to use the skin as to transmit the power. And because it will have power loss, so that's why at the very old days they try to do a hollow tube. So it is actually a Hoover Dam cable in 1930s in America. They really use this kind of cables to transmit the electricity. A hollow tube, but nowadays they don't use this one. Yeah, because there are some other problems, and just know that skin effect. High voltage, high frequency, the electricity will try to transmit at the skin, not the core. So you can just remove the core and to try to save some materials. 2 windings transformer. 2 windings mean we use 2 coils. Okay, in some words, in some textbooks or some reference, they try to use a word compared with auto transformer. Auto transformer just use 1 circuit, 1 coil, right? Or we say 1 winding. 1 coil means 1 winding. It's just the same word. They will use isolation transformer, but it's not accurate. Isolation transformer will use some plastics to separate these 2 coils, so that you don't touch it. Okay, this is a 2 windings. The more means 2 coils. Okay, and this is for your, not for reference, but this is common to be seen. Okay, dot conversion. Okay, why I have to mention this one? It's because when we do the transformer later time, you will see that if we don't do additional stuffs, the phases will change. Okay, you see that's the lower part. The phases will change. It's a 180 degree flipped. So in nowadays, for transformer, they will add a dot here. So if you see the dots are matching, they are in the same phase. But if the dot is not in the same way, it's flipped. Okay, and we have special treatment for this one. So the coil winding is not the same. That has a very quick break first, because I want to try and drink some water. I really want to try to do it as quick as possible. I don't want to come back tomorrow and clean my stuff. Actually, I have already prepared the questions for you. I just extract them from the reference book, so you can try to do some. Yeah.
Just send us the PDF.
Yes, I can send you the PDF.
Next week, you do.
哇好啊好啊好啊！太好啦！我好肚餓。
我有麵包，
多謝，我可以睇得夠。
食邊個？即係個齋嘅。
真㗎？我想食朱古力。
嗰啲吸引叫。唔使啦，多謝，我都有麵包。
好多嘢學㗎啦。
HARTS。
好啦，佢哋唔知邊度買。Actually, I have 再講下先啊，我哋而家未。其實我喺好耐以前咧，我自己喺 HARTS 咧有份呢個嘅自己思考嘅 notes 嘅，喺個 Notion 度。咁如果有人親自去睇過咧，其實 OK 嘅，你可以同我講，我可以 send 條 link 俾你。但就 Notion 咯，係啊。我係自己嗰陣時嗰啲notes 嚟嘅，係就係嗰陣時BK Sir 教我自己有份基本上就齊晒嘅呢度啲嘢，基本上我都係跟住一個 flow 去做。基本上，所以點解話我 cover 嘅 materials 喺英文咧，一定會 cover 晒cover 起碼80至90% syllabus 嘅。但係剩低有啲嘢咧，佢好似咩雙環數嗰啲咧，我教唔切嘅應該會，同埋佢淨係出一條就算啦。通常我哋都係講話份卷咧，如果你真係温晒書咧，通常就係啱到80到啦，即係八成幾啦，已經好高啦。但係其實佢因為其啲嘢咧唔係好難嘅啫。咁剩低嗰2成係發生咩事咧？就係佢拎嚟睇下冇高手嘅啫。因為佢呢份卷咧，佢會拎出去俾其他國家睇嘅，證明話我哋份卷好難啊！好多人都即係有啲問題好難啊，所以份卷嗰個定位係好高嘅。但佢哋就唔知道我哋一半就合格咯。出邊有啲人通常都係要7、8成先合格嘅，或者係中國好似係要20幾 over 35先至合格嘅，28 over 35先合格。所以就係咁咯，俾人睇嘅啫。所以唔好驚，如果見到唔識嘅問題 skip 咗佢先，後邊嗰啲一定淺啲嘅，係就係咁。呢個我覺得自己寫得唔錯，你可以拎去睇。我真係覺得自己寫得唔錯。有冇嘢留咧？我睇下自己冇嘢留先，趁呢個休息嘅時間。冇啦。今日應該講埋 dial 就差唔多啦。
如果考完呢個牌咧，入中國又要考中國個牌㗎。
我諗先啊。佢哋好似話係嘅。
中文嘅。
low 散咯，就係啲嘢其實簡單啲嘅，其實佢好似話可以串數嘅，但係啲人話寧願考會方便啲咯，因為佢哋好似話係中國嘅 A 牌咧係背書嘅啫，300條題庫，佢淨係抽35條問你， 咁你背晒個題庫咧，基本上就 pass 嘅。所以佢哋話大陸個牌係簡單，一 exactly 嘅啫，頂多係啲次序調咗嘅啫。點解佢哋話簡單就係咁解啦？但係大陸難嘅地方咧係在於佢會，如果佢俾你轉咧，佢都頂多係俾你轉上 B 牌嘅啫。大陸有分 A、B、C 3個牌嘅，係啦。咁 C 牌就真係考嗰啲 theory 考到好金啊！係咪咁？好啊好啊，因為食緊啱翻去做早餐啊。
先就特登買多幾個俾你㗎。
以前仲係學生嘅時候咧，可以翻屋企，唔係即係可以喺油塘嗰度買嘢過嚟食嘅。但係你自己即係轉咗工之後咧，都唔係轉咗工，因為工作情況有變咧，咁就喺觀塘過嚟咧，咁就冇嘢食。
佢哋意思教我哋 cyber security 啊？
係啊，唔係因為我而家要喺觀塘耐唔耐要翻工，嗰度茶果嶺道過嚟就好快，但係就茶果嶺道就真係冇嘢食咯，好慘。
日頭有嘢食嘅，
係
係即係收咗啲工廠咁啦。
咁就算啦，寧願翻屋企食嘢。我睇呢度有幾多嘢講先。呢度簡單啲嘅，唔使咁擔心。
呢個字我都記得，完全忘記咗佢要咩。
一層次講得咁快，乜班書咁講得咁慢嘅我？錯咗喺邊度咧？點解會講咁慢？教計數，不過教計數係冇辦法。Still good 啊！Oh, I have to remind all of you, your exam will be held in 11th of November. 11th of November. 你唔使考啊嘛。So if you are going to take the HKRAE, you can register now.
Now?
Yeah. Or just go back home to do it. Yeah. Or because they will have some space are limited. You don't know how much space they will provide. Okay. So if you already know the date and you can reserve 11th of November, so you can try to
This week we'll register.
Yeah, try to register.
你俾呢個 link 俾我哋啦。
好似好耐以前有一條 link，唔緊要再俾過啦。等我揾一揾先。
輸咗最低個仔食飯啦。係9空最熱嘅最呢啲。
唔使驚you don't know the score, you just know pass or fail.
Yep.
So yeah. But if you know you are fail, then I don't think you guys will fail actually. Yeah. Don't 輸咗請食飯，真係輸咗請食飯。
fail 咗先生請食飯。
真係得。你有上齊堂咯，請你食飯，咁都 fail 咁冇辦法啦，係咪？即係個自問都要教嘅嘢都教得七七八八嘅，咁冇理由 fail 得咁熟咁多嘅，係咪？
佢唔會話俾你聽你 pass 幾多嘅。
佢唔會話俾我知 pass 幾多，佢淨係話俾你知 pass or fail。係啦。Let me go back home and have a quick check. I will provide the link to you later time, because I forgot it. But when I do the registration, I found that it's quite the link is quite hidden. You don't know where the link is actually. It's not in this page. This page is talking about when the exam to be held, but this link does not provide information for you to apply for the exam. Okay. Yeah. Let me check if how to apply. Did they give you the? Yes, no, they didn't give you.
喂，仲有8分鐘啫喎，
9點半啦，冇辦法，唯有冇得早收咯今日。Okay, let's continue to our class. But I'm worried that this slide cannot be finished. So if that's the accident, then I will go through it later time. Okay. Okay. Semiconductor diode. Diode is the electronic components that will just allow the electricity flow in a single way. Okay, it is the basic definition. But of course, there are some more add-on. So we'll talk about it one by one. So the P-type and we've got in the world we got P-type semiconductor and N-type semiconductor, and the P-type, P means positive, so it have a lot of hole. We say that they carry a lot of positive charges, okay, and we think this kind of positive charges are holes. In Chinese we call it 空穴 or 電子空穴. Why we are saying this? Because it is an electron acceptor. It accepts electrons. So you can think it is electron dropped in the holes, okay? That's what we call holes. And for N-type, N spin negative. So you know that it is full of electron because electrons are negatively charged. They are electron donor. They are actually they are in class 5, so they have one extra electron, and P-type is lacks one electron. So that's why when you combine both of them, it becomes a NP-type semiconductor. The electron can flow from negative to positive, okay? Electron can flow from negative to positive. So the current will flow from P to N, okay? So it's for your reference, okay? The hole is not really a hole physically, but it's just a place to accept electron, okay? But you can think it as hole. It won't affect your judgment. Oh, you say yeah, it is the aluminium, and SP is for I forgot. Just group 1 and group 3 and group 5. Never mind. The physics, if you don't know the physics, never mind. Okay, we'll talk about the P-type semiconductor and N-type semiconductor, holes and electrons, and we have to talk about the NP junction. The NP junction is important when we talk about the Zener diode, a special type of diode, which will be included in which has been included in your syllabus. Okay, when we connect both N-type and P-type together, the connection part is we call NP junction. NP junction, the place where P-type semiconductor and N-type semiconductors joins together. Okay, so that's yes, okay, NP junction, just a word. Diodes, you see that the NP junction acts as a one-way switch, which allow current to flow in one direction. Okay, which is the basic understanding. So you see that the electron. Wait, let me see. Forward bias. Yes. This arrow is wrong. Fine. This is just think. I will change this picture. This picture is not good. This is the electron flow. Okay, just think of the electron flow. The current actually flow from this way to this way. If we connect it in this way, the current flow in this way. Okay. this we call a forward bias. But if it is a reverse bias, the electron cannot be flow. Okay.
Doesn't it flow from negative to positive?
No, this positive and negative, I guess this is just the voltage difference. The voltage difference,
voltage
okay? The voltage difference. Okay, so when the circuit is doing this way, this part have a higher potential difference over this one, so that the current will flow in this way. They get electron flows from negative to positive, okay? This is electron flow. But if the circuit in this way, only the current can flow through from the anode to cathode. If it is in reverse way, the current, it will block the current, preventing the current going from this direction. I will change this picture, never mind. If you have printed it, I'm so sorry. You have to print it once again. Just this page, okay? I will change it and I will let you know later time. Okay. Oh, I have to, yeah, never mind. Yes. I forgot about this one first. So, this is the symbol of diode. The triangle one, they got a line is cathode, which is supposed to connect to negative, and the other side should be supposed to connect to the positive side, okay? And LED will be talked later, because this is a special type of diode. Okay, current voltage characteristics. For every kind of semiconductors, they have a threshold voltage, or we call it a barrier voltage. Okay, they will only activate, which means the current will only flow if the voltage is about the threshold. Okay, and we got two types of semiconductors. For the diode, two types of diode. It can be made with silicon here, or germanium, silicon or germanium. Okay, for silicon diodes, the threshold is around 0.7 volt, and for germanium, it is around 0.3 volt. Which means silicon has a higher voltage. You need to apply a higher voltage in order to drive a silicon diode, and germanium you just need a much lower voltage. Okay, which means, in other words, if your circuit does not have greater than 0.7 volt, the current may not be able to flow through the diode. Okay, this is the current voltage characteristics. So you see that the voltage flow here, right? If it is just 0.1, it is 0, right? Yeah. The current will only flow if the voltage above threshold is applied. Okay, reverse bias. If we inverted our diode, as we just said, diode is one way, right? So if we flipped our diode, the current will be blocked. Okay, the current will be blocked. So you see that they can accept a very large voltage, right? And the current remains negative, very low. Okay, very low. If even if we apply the high voltage, like let's say a 5V or a 10V, the reverse current is very low, very low. Okay, but not exactly 0. But for your convenience, you can just treat it as 0 yet. Okay, reverse, no current, unless you give it a very great voltage, like hundreds or thousands of voltage. The diode will break down and it will start to allow current to flow through. Okay, this is not in your exam, but connecting in forward bias or reverse bias is important. It's because we got a special diode, Zener diode, and we use it as a capacitor, which needs to be connected in reverse bias. We try to make use of this. Even if we increase the voltage quite a lot, the current remains very low, near zero. Okay, we make use of these characteristics for Zener diode. Yeah, that's why we don't use it just a forward way. We will also use it at the reverse way in special condition. Okay. LED, special type of diode where they will have light. And PK mentioned that they try to trick the student so that they cut the legs, and the student get confused. They don't know how to distinguish the anode and cathode. But this is just for reference. Never mind. Just know that LED is a special type of diode which can emit light. That's all you need. Okay, that's all you need. You see that, hey, this is, you see that, P type, N type, right? This is just like a normal diode. Yeah. Zener diode. Zener diode is important because LED appears in your syllabus. And Zener diode, it also appears in your syllabus, which is, you see that Zener diode use the reverse voltage characteristics. Even if we give a lot of voltage to it, the current remains near zero before it breaks down. Of course, we can't give it a very large voltage, right? If we give a very high voltage, all the stuff will break down. Just like in the lesson 3 I've told you, everything can conduct electricity. Just the matter is how much voltage we have applied, right? Okay, remember that Zener diode is special. You have to connect it in reverse bias, reverse voltage characteristic, reverse, okay? So and this actually works as a capacitor, and if your circuit works in 10 volts, but your voltage input is 12 or even higher, it will help to limit the voltage to 10V to protect your circuit. So it also helps to stabilize your voltage. That's why we call it, sometimes we may refer to voltage stabilization diode. In Chinese it's called 穩壓二極管. 穩壓二極管. But in English we just call it Zener diode. Yes, this is what we call clipper. So you see that after we put actually I use quite a lot of time to find this picture. This is a very good picture. You see that if we don't have a Zener diode, the voltage may be very great, over voltage when we turn on. But the Zener diode helps to stabilize the voltage so that it won't go too high. It limits the voltage to the voltage where your circuit should work. Okay, so if there is any fault here, it can help to absorb a lot of the voltage.
How does the Zener diode look like?
This one, yeah. I don't know if let me ask PK so if he have got one physical example here, but I'm not sure. But if you see that it is how it looks, okay. Yeah. And the sign here, they got two legs here. For a normal diode, it's just straight line, right? But the Zener diode, they got two legs here. So if you see these legs here, you know it is Zener diode, and it should be connected in reverse bias. Yeah. It absorbs the voltage to prevent. Okay. Which makes use of the reverse voltage characteristics. Okay. Once again, for bias, so we know that the diode will only works when the voltage, for a normal diode, it only works when we have a voltage higher than the threshold. Okay, only high threshold it works. But for signal diode, we will see that, hey, I give a lot of reverse voltage. I gave a lot of voltage here. What about the current? The current increased just very little. The voltage just increased very little. Okay. Oh no, I'm sorry. If the voltage is very large, the current will just increase quite a little. Okay. Like if I give 10, increase 10 V or 100 V, the voltage may just increase by 0.1 or milliamp or 100 milliamp. So this can help to absorb a lot of voltage. Yeah. It just used like a capacitor. I'm not sure, but I will try to see if there are any calculations for signal diode, but I don't think you need it. But you have to remember that signal diode, if you see the signal diode in your circuit, you know that what is supposed to use, what is the use of it. Rectifier is is a device to help to convert any AC to DC. Okay, any AC to DC. So do you still remember what is AC, what is DC? I hope you remembered it. Let me check if I got my good friend with me. iPad is really good. I really love my iPad. Hey, where's my? Let me just a minute. Hey, I never mind. You know that I'm not going to explain it once again. Cause I can't pull up my iPad anymore. They say it's disconnected. I'm so sorry about it. Okay, let's continue. Rectifier. So it's just a sine wave to a straight line. Don't worry about it. Okay. Under rectifier, we'll introduce 3 types of rectifier to you. A half wave rectifier, a full wave rectifier, and a bridge rectifier. Okay? 3 types of rectifier: half wave, full wave, and bridge rectifier. For half wave, hey, you see that it's easy, right? Just a diode. What is the use of diode? It just allows the positive voltage to pass through, right? So that when you attach a diode here, only the first part will can go to your circuit. Okay. It is the half-wave rectifier. Very simple. Just one diode is enough. Yeah. Easy, reliable. But it only converts the half of the cycle, so that it does not utilize the AC. Okay. Full bridge rectifier. So you see that you have to draw a line here. It is a ground. So the circuit will separate into positive and negative. Okay. So for the negative part, it will, when it is negative phase, yes, it will split the circuit into positive, 0, and negative. Okay, so the negative will flow, so it becomes a combine of them. When this part is at the max, this part is minimum, so that this part will not transmit, will not have current flow through, will not have voltage flow through. So this part is from here. Okay, so the phase is flipped. So when the second part is positive, it becomes negative here, and negative is blocked by this diode. This part is allowed to this diode, so it becomes 0, and the second here can go to the output, and then turn it on and off here, first part, and second part, first part and second part. Okay, so that's why it's like a absolute value, huh? How should I address it? Sine wave. Okay, every peak of sine wave. It's a full wave rectifier. Use of just two diode, but you see that you need to make a line here to ground it. You may see different forms of rectifier, halfway and full wave, but if you are not sure about the circuits in your exam, remember two stuffs. For full wave rectifier, they must have an extra line for this coil. In the coil, they have 3 points. Okay, they have 3 points, and only 2 diode is used. Okay, so it's a bit weird. You have to attach an extra line in the middle. This is the properties of the full wave rectifier. Yeah. Okay. And the last one, and the most famous one, is the bridge rectifier, which is the same as I have shown you in this picture. This circuit is nearly equivalent to this one. Okay. This is how the full bridge rectifier works. Okay, so you see that it splits into 2 cycles. For the first cycle, this circuit becomes here, and the ground flows from here to the coil. Okay, this is this diode and this diode do the cycle. Okay. So actually it converts this whole negative part into positive actually, using a diode. So you see actually the connection flipped at the negative side. Okay. They may give you the diagram and ask you which one is the correct full bridge rectifier. So you see that it have a very great characteristics. It's like a V shape. Okay, from here V is a V. Okay, V shape. This is how you draw the full bridge rectifier. Okay, and at that time PK sir really do it phase by phase, but I think you can. If I give you the GIF, then you can know which phase is when the work is doing. Okay. Okay, another graph. Okay. Let me see. This one here. Yes. At the positive phase, it will flow through D1 to here and D3 back to the input. Okay. So, but if it is negative phase, it will become flow from D4 to D2. Okay. Positive D1 to D3. Negative D4 to D2. Okay. So it's working pair. At first phase, this 2 is used. Second phase, this 2 is used. Okay. 0 to 90, this one. 90 to 100, this one. 100 to 270, this one. 270 to 360, this one. This is how it works. And you see that when for the output of every rectifier is just flipping the negative sine wave to the positive side. Okay, so you have a lot of ripples when you really use it. So we want to smooth the curve, make it try to as straight as possible. We will make use of this capacitor. Okay, the capacitor is still remember the last lesson? Capacitor is used to store electric energy, right? So when you see this one, okay, when the charge becomes very low, the capacitor will try to release energy and try to maintain the voltage until they receive a voltage higher than the capacitor can output. Okay, so you see that the ripples will be smooth a lot. The larger the capacitor, the smoother the curve. Okay. So that's why if you see that a very large capacitor is used for a rectified in a bridge rectifier. Yeah, that's why. It helps to stabilize the voltage, maintain it as strict as possible, maintain the output as strict as possible. Okay. Ripple voltage. The only thing they will ask about ripple voltage is ask you to calculate. The definition of ripple voltage is minimum, maximum minus minimum. That's all you have. That's all you have. Like it's an example. They give you 2 voltages, right? Maximum is 12.15. Minimum is 11.9, right? What is the ripple voltage of it? Maximum minus minimum. That's all. Yeah. If they really ask you this question, but in my exam I didn't meet it. But I don't know why they need these keywords in your syllabus. That's why I have to explain to you. Yeah. Because sometimes the voltage output may not be as strict as possible. You see that this one, right? Even I have a capacitor, they have some ripples in it. In Chinese we call it 波. Yeah. That's why we have a special term to measure the current fluctuation of the current. Yeah. And I guess we okay, let me finish up to the filter parts. Okay, I will talk about slides. We'll finish the class once we finish slide 62. Okay, just give me a few more minutes. Okay, filter. What is filter? Filter is common blah, blah, blah. Okay, in short, it just allowed a special frequency to pass through, or a blocking frequency that we don't want. Okay, we've got 4 types of filter. Low pass filter only allow low frequency to pass through. High pass filter, high frequency to pass through. Band pass filter allow a special band to pass through. And band stop filter, the band here is blocked, okay? Only allow frequency lower or higher to pass through. Okay, so I will go through it one by one. Now, okay, so you see that I have talked about what is 3 dB to you, right? The minus 3 dB points is where the voltage is 1/√2, or power is halved. This we call 3 dB points. Output is halved. I've shown you the calculation. So yeah. So we are saying that if we want to measure, tell others what is the working frequency of this filter, we will try to tell them, hey, where's the cutoff frequency? What is the cutoff frequency? From where to where this frequency works, or allow the signal to flow through. We will tell others the cutoff frequency, and by definition, the cutoff frequency is the negative 3 dB point, the minus 3 dB point. Okay, like if I say this point is 3000 hertz. Okay, I define this point as 3000 hertz. I would say that the cutoff frequency is 3000 hertz. Okay, even there may be some very little signal flow through, but already at this point, power is halved. I would say this point is the cutoff frequency. It's just definition. You can't argue with others why we have a different standard. Yeah. But the most easiest understanding is because the power is already halved. And after this point, the output will, the voltage will drop drastically. It's log, right? So you know that the log is. Let me draw the curve to you once again. For a log scale, the power just flows like this. So if it is already the 3 dB point, the power is half. So you see that it's dropped very drastically. The power is very low at the point, which can be neglectable. Okay. That's why we have the definition like this. Hey, my battery is running out. Okay. And simple low filter. I have to talk about this one. Still remember that we mentioned inductance and capacitance, right? Capacitance only allow low or high frequency to pass through. Just take a look at this part first, okay? I'm going to talk about this part first. This part I'm going to explain it later time. We'll go back to this circuit. This is a very common low pass filter because this capacitor will have a very low impedance when at high frequency. Capacitor, capacitor, high frequency, low impedance. Okay? Still remember that formula? Oh, because I didn't connect our iPad, so you have to figure out the XC formula. Or you ask me after class. I cannot go it now. I'm so sorry about that. But we are going to end that. Never mind. Okay. XC equals to 1 over 2 pi FC, right? So when XC is increased, frequency is low. That's why when we say that for a high XC decreases when frequency is increased. So that's why we say that when the frequency is very high, the capacitor will have a very low impedance, so that the current and voltage will flow through it. Okay. So that the high frequency signal will follow the capacitor and be ground. Do I need to draw it once again? You can see that now, or not? X. This formula. So you just take a look at this part, and this part, and XC is inversely proportional to this part. That's why we say that it's very suitable to use as a capacitor, low pass filter. Okay, because the high frequency signals will follow this capacitor in the ground, and leaving the low frequency signal to the back. Okay, and this is in reverse way. Okay, this is a reverse way. I'll explain it now. How about for inductance? Inductance, the formula is what? What is the formula? The formula is X. Can you see it? 2 pi FL, right? So that when XL increases, F increases. So that it blocks high frequency signals. It blocks high frequency signals, only the low frequency will pass through. Okay? So that's why you see that the load and the capacitor is flipped. It's because sometimes you just have you know that when the inductance is used and when the capacitor is used. Yes, that's why they're flipped. But if you can't remember it clearly, just remember the left hand side. Okay. Low pass filter, most of them are capacitor. Only allow this is for your extra reference, but I guess you need to know it. You need to know it. Yeah. High pass filter. Once again, high pass filter. 3 dB points I've explained to you. Inductance is because it's when frequency is very large, the impedance is also very large. But if the frequency is very low, the impedance is also low, which acts just like a conductor, and the current will flow through here. And your high frequency AC signal will go to the bottom, will go to the rest of your circuit, and you will not flow through the inductor. So you see that if you compare this graph, compare the left hand side. The load is here, right? Low pass filter, the load is here. The load is here. That's why I have to use the same setup here for you. If we just change this part from capacitor to inductor, it can be changed from low pass filter to high pass filter. Okay, but this one is flipped design. Okay, flipped design. Trying to block the signal instead of grounding the signal. This part, all of them are grounding the signal. Okay. So if you can't memorize this one, just use the left hand side. Just use the left hand side. But I need to tell you that because of the characteristics of the impedance, you can always change the components if you don't have the correct if you don't have capacitor or inductor in hand. Okay. Bandpass filter. Bandpass filter is just a combination of low pass filter and high pass filter, and so that only allow a range of frequency is used, and we'll have a low cutoff and high cutoff. The 3 dB point is the measurement of it. Okay. And the band stop filter will only allow frequency lower or higher. For the band here, it will blocks. Okay. See if you understand what is this kind of filter, which filter will this circuit falls in? Low pass filter, high pass filter, band pass filter, or band stop filter.